Hello dear students, let's see how to construct pushdown automata for language. L is equal to, L is the language, a raised to n, b raised to n, such that n is greater than or equal to 1. Just observe this language. A raised to n followed by b raised to n. That means all strings must begin with a, and if there are n occurrences of a, then those n occurrences should be followed by n occurrences of b. Exactly same number of b's. So, and n should be greater than or equal to 1. So, we can't have an empty string. We can't have a string in our set as a raised to 0, b raised to 0, which is epsilon. We can't have this because n should be at least 1. So, we have a language where smallest string is ab. You can check this is a raised to 1, b raised to 1. Then this is a square, b square, 2 a's and 2 b's, and so on. So, we want to write a machine, we want to construct a machine or automata called pushdown automata, which will recognize all these strings. Just some observations, silly observations actually it is, but natural, you know this, that the first symbol of the input string must be a. So string cannot begin with b because check the rule. It is a raised to n, b raised to n. So such a string double b double a should be rejected. I mean, this pushdown automata will accept only those strings which have this form, a raised to n, b raised to n, and the pushdown automata will reject the strings which are not of the form a raised to n, b raised to n. So if you input such a string, double b double a, then PDA must reject such a string. Also, the second observation is a cannot occur after b. That means imagine you have a string double a, double b, and then again double a. Although the string is valid till this point, you watch 2a followed by 2b, but you can't have a again because we don't have a string of the form a raised to n, b raised to n, a raised to n. This is not the rule asked. So this is also invalid. That means a should appear in the front, b should appear at the end, number of a's should be equal to number of b's, and a cannot occur after b. Now, what is the idea? Very simple idea to actually develop a PDA. Now, note that you all know that PDA has a stack. I'm drawing only a section of PDA. PDA has a stack. I'm not drawing states and the input tape and all that. Now, this stack is initially not empty. All of you know from our earlier discussion that we will put some initial symbol on the stack. Stack is not empty initially. When the PDA starts, the stack is not empty initially. Some symbol, some special symbol is stored on the stack. Okay, so let's say Z0 is there on the stack and the input is double A double B. Just imagine this is the input string. Now what is the idea is that we will start reading the string from the first symbol, and if it is A, if the symbol is A, then we will push a special symbol X on the stack, and then we will continue reading the next letter. If the next letter is also A, we will push X on the stack. That is, for every A, we will push X. Now, why are we doing this? We are doing this because on reading A, we want to remember that we had read A. We had encountered A. And how are we remembering it? By pushing X 2 times. Now, these 2 occurrences of X indeed is a track kept, is an account kept that we got 2 A's in the past. Now, as soon as we get a B in the input, just check, we will do exactly opposite. We will pop 1x from the stack. We will pop this. Why we are doing this? Because on reading B, we are saying that we should cancel 1a, isn't it? Because number of A's must match number of B's. So cancelling A means removing 1x from the stack. Now have a look at this. If we have got another B read from the input, then we will also again pop 1x from the stack. Popping an X from the stack means we are cancelling out one A that we had stored in the past. And now we continue reading the input, but now the input is over. We show the input is over by epsilon symbol. That is, the input tape now has epsilon character. We are reading an epsilon empty string. Now you watch, if we are reading an empty string, that means the input is over, correct? Now, what if the input is over? What would you suggest? What was our problem? We wanted to check whether the input is input of the form a raised to n, b raised to n. Now, input is of the form a raised to n, b raised to n if number of a's that were pushed in the form of x have been cancelled because same number of b's were encountered. Now, as soon as we read this epsilon, we just ask the question, is stack on reading epsilon, is stack containing only z0 on the top? Is stack containing only z0? That means whatever a's you pushed in the form of x, are they removed? That means, is the tally of number of a's and number of b's matching? If only z0 is pending on the stack, then we would say that the input is valid and it was in the form of a raised to n, b raised to n. Let's elaborate this idea. Let's say that the input given on the tape now is A, double A and triple B, let's say. Now you know that this input is not valid according to our rule of the language. Now we have a stack again, start with Z0, and as soon as you encounter A, you push X. To remember A, second A will also result in pushing X. Now as soon as you encounter first B, you will start popping. So you have cancelled one A, correct? Again when you read B, you will pop one more X. That means you have cancelled another A. Now when you are reading a B, just observe, you don't have epsilon yet, you have one more B in the input. When you get a B, what do you expect on the stack? Now when this B, which we are now reading, this one, this B is red, current B is red, then we expect X, on top of the stack. Tell me, isn't it true? Because if there is a B, then there should have been a A. But notice the top of the stack is Z0. We don't have X pending on the stack. What does it mean? That number of B's surely are more than number of A's, because the number of symbols X that we pushed are less than number of symbols that we can pop. As we are having top as Z0, we are not having X on the top. We will say that A square B cube is rejected. I hope you have understood. Come again. Although the idea is very easy, these discussions will be helpful in very easy understanding of development of PDA. Just imagine that the input now is, let's say, double A single B. Just check, this is also not valid. So what are you going to do is, Z0 is initially on the stack, and for A you will push X, again for A you will push X. Now for B you will cancel one A by popping X. So you have cancelled one A. But now you have reached epsilon. Just check, you have reached the end of the string. Now when epsilon is reached, that is end of the string, what do you expect on the stack? We expect, come again, what do you expect on top of the stack? We expect Z0. Yes, we expect Z0, because if the end of the string is reached, then all B's must have cancelled all A's. But note that on the top of the stack we don't have Z0, we have X. That means surely one more A is pending to be cancelled. That means one B was missing. So A square B raised to 1 is rejected. I hope the idea is very clear. We will come back in the next example where we will see development of this PDA. Okay, thank you very much.